Structures and classes present complex data types. Classes are specific for C++ and not all programming environments support it. For example, STM32 in hardware abstraction layer framework mode doesn't provide one, and only the use of structures is available to the developers. The Arduino framework supports structures and fully functional classes. Classes are considered part of object-oriented programming, while structures are an early prototype of classes containing data only, without the data manipulation code. Structures are used to group related variables of simple or complex types. Those variables are stored called structure members, or sometimes referenced as fields. Those variables can also be of other structure types, so a structure can be composed of other structures. The general idea behind structures and classes is to encapsulate common and related data. For example, a first-in, first-out queue that requires a buffer for queue data, but also indexes representing the head and tail of the queue. It is possible to declare a structure as a one-time variable or as a type and reuse it in multiple contexts. Structures are reference type variables so that when they are passed as an argument to the function call, they should be referenced by the address. The fields composing structure are referenced with a dot operator. It is also possible to provide all member variables in the declaration to initialize a structure. This speeds up the initialization process and simplifies code significantly compared to the initialization method using the member-by-member approach. Structures can also have a member functions in C++, which is a building block of classes. That is not the case with C or poor C++ implementation, such as, unfortunately, STM32 in HAL mode. In this case, a developer's rule of thumb is that the structure is accompanied by a set of data manipulating functions that are external to it. An unwritten rule, in this case, says that the first argument of such functions should be a pointer to the structure. It is possible to dereference the structure's member fields using a pointer and an arrow operator that is written as a minus and greater than character in a row. Such structures, along with functions that process their data, are usually encapsulated as a library in the form of header and accompanying C source files. Classes are considered a development of structures and were introduced in C++. They can be considered as an encapsulation of data and data processing functions. However, classes provide more features. Among others, those features are special functions called constructors and destructors that are executed when the class variable is instantiated as an object and is being destroyed, respectively. A constructor is usually used to initialize an object on the logical and technical level, such as zeroing indexes, initializing members with data either provided by the default or provided as an argument to the constructor function, and allocating dynamic memory. A class can have multiple constructors with different arguments or no arguments at all. It is the developer's duty to foresee all class use cases and implement appropriate constructor versions. In most cases, there is no obligation to implement a constructor. Class destructor, on the other hand, is executed when the object's lifetime is finished. Its purpose is to clean up so that the destructor function may free the dynamically allocated memory, inform other codes about ending its existence, and so on. The destructor doesn't have any parameters. There is no obligation to implement a destructor. The class body can declare any number of member functions that manipulate the data or perform other tasks. Member data fields and functions can be marked as public or private. Public functions are accessible externally from the code that uses the class variable or object, while private ones can be executed only internally by other member functions. The great power of classes and object-oriented programming is that classes can be inherited to enrich or change their scope and behavior. There is no need to implement everything from scratch so that a class can constitute a solid background for another. In IoT, classes frequently represent a hardware component such as a sensor, actuator, or communication class. Please be aware, however, that embedded C++ may be limited compared to regular C++ environment for Windows, Linux, or Mac operating systems.